Hello, my name is Carlo Gutierrez, and this is my final project for Introduction to Material Science, and I decided to do it on graphene. Graphene is a material that is made entirely of carbon, at least in its pure form, and it is only one atom thick, just one atom of carbon put together in a hexagonal kind of honeycomb-like structure, and it is the thinnest material known to man that is able to remain stable while still being open to the elements. And so, some history on the material from 1990 to 2004, there was definitely attempts to create it that were being done, that were happening. And it was done using mechanical exfoliation, which is basically where you take a piece of graphite, and graphite is essentially many layers of graphene stacked on top of each other. So you can kind of think of graphene as like the monomer layer of the polymer graphite. And what they did was take graphite and just layer by layer dissecting it until one layer remained, which was the objective. But in this time period, there were only, or people who attempted to create graphene were only able to get it down to about 50 to 100 layers thick. But then in 2004, a group from Manchester was able to extract graphite crystallites, which is graphene, that were only a single atom thick. And so that was the first, or one of the first, and not the first, successful production or extraction of graphene. And there was skepticism that the finding was met with, until a group from Columbia University was able to support the first group from Manchester, their findings on the material, and it's kind of ushered in an age of possible graphene production. And so why would one even want to create such an infinitesimally small material? And the reason is many reasons, actually. It's quite strong, 200 times stronger than steel, and the density, or more weight to surface area ratio for graphene, is very small compared to steel, as you can see on the screen. It also is a great conductor of both electricity and heat, and this is partly thanks to the two-dimensional structure, which allows for a very efficient transfer of energy from one atom to another. And there were some early studies that suggested that the thermal conductivity of graphene could be size dependent, but nevertheless it's still a promising material in that regard. And when it comes to light absorption, it has some interesting abilities, because on its own it's not that great. But if you add in some impurities or integrate it into materials like plasmonic structures and metamaterials, it can really improve this capability. And so some uses of graphene are that, jumping or piggybacking off of the last slide, is that it can be combined with other materials. And there's three main areas that I found that were pretty cool to talk about. Paint and coatings. If graphene is used and integrated into those fields, you can produce some paint that's quite resistant to corrosion, abrasion, to the growth of microorganisms. Anti-fouling is more in regard to like marine life, so like marine microorganisms, while antimicrobial is more like mold, algae, things that can be more found on land. And fire retardant basically means that it can slow, if not stop, the spread of fire. And so when it comes to biological engineering, the bioelectric sensory devices that it can be integrated into can help things like monitoring glucose, hemoglobin, cholesterol, even DNA sequencing and tissue regeneration. And when it comes to optical electronics, there is a material called indium tin oxide that's pretty popular in the field. And graphene has been shown to perform at a matching level to indium tin oxide, or indium tin oxide, excuse me, on top of having some extra properties. It has high tensile strength, that's while also being able to remain flexible. And in the field of optical electronics, that is quite valuable. And so some of the latest news on graphene is shown on the screen now. The two that really stood out to me the most were number 3 and number 6. Magneto-resistant material refers to more graphene's ability to change electrical resistance in response to a magnetic field, and it's able to do this at a faster and more pronounced rate than other materials, while also being at room temperature too. And when it comes to number 6, there was a successful creation of a graphene semiconductor that was found to allow for the transfer of electrons at a more efficient rate than silicon is able to do. So this could mean some really promising, future stuff for technology, faster, more efficient computers, phones, things of that sort. So yeah, graphene, definitely an interesting material. Here are my references, and yeah, thanks.